So I'm going to help you find the worst risks. Actually, I'm going to define a lot of things too. But let's get going here. First, I'm just going to introduce myself. I'm going to figure out who you all are. There's where worst risks comes in, is I'm going to describe what a cloud-native application protection platform is, talk about toxic combinations, and how to get started with this stuff. So we can start with me. Here's who I am. My name is Gabe Schuyler. I work for WIZ Incorporated, right over there. And I'll be over there for the rest of the day if you have questions, or I can take questions here too. I've been doing operations and DevOps forever. I work at WIZ now, but I used to work at Palo Alto Networks, and then Puppet Labs, and Sony PlayStation, actually in the credits of over 20 video games. So I've just been doing ops forever. Cybersecurity has always figured into that. It's always been part of it, but now I'm really, really focused on it. I'm curious to know who, or I guess kind of why you're here. Like who's like a total cloud native, everything's in the cloud. Good. I like that. Some of y'all, I imagine, are cloud first. Like people are saying anything new has to go into the cloud. Are y'all playing with containers or serverless functions yet? Cool. All right. Good. I like that because this is going to be a real introductory talk. I'm not gonna go crazy with acronyms. I'm going to start with one acronym, but I'll be explaining all my acronyms as I go. This is what you're here for, and the title apparently has been different in a couple of places, but we will be finding the worst risks in your cloud using a cloud-native application protection platform, which is, it's a new term. Gartner coined it, I think, a couple of years ago. And the reason why they did it was there were numerous point solutions in the world, but they really needed to be pulled together into something singular. So what we had previously were point solutions like security posture management, workload protection, and infrastructure entitlement management. The cloud security posture management, when you see this, folks are probably going to abbreviate it CSPM. And what that really means is just how things are configured in the cloud. You've got the shared responsibility model in the cloud, which is that cloud providers, they keep the lights on, they keep the credit card machine working, but how you configure your cloud resources and what you run on them is your responsibility. So the first part of that, how you configure your cloud resources, that's what they call Cloud Security Posture Management, CSPM. The other part of that shared responsibility that's on your shoulders is what you run out there. And what we talk about in the cloud is cloud workload protection platforms. This is a role that traditionally might have been given to an EDR or XDR platform, some anti-malware software, but in the cloud, everything's moving faster and can't wait around a lot of times for agents to get installed, to get logged into some central system. Because they're disposable, you take sort of a disposable attitude towards them. A cloud workload protection platform, which people will just say CWPP, that's about the running workloads that you've got: virtual machines, containers, and serverless functions. Cloud infrastructure entitlement management is really just a big way to talk about identity. One of the really interesting things about the cloud is that it's not just users that have permissions to do things. Workloads themselves have permissions to do things, which gets really interesting because a workload doesn't log in to Active Directory, for instance. In the cloud, it can now do things that it has been granted by its role. So for instance, you'll see attacks where somebody finds a vulnerable resource, they exploit it, and then the, for instance, virtual machine that they get onto has the permissions to create other virtual machines. Imagine Continuous integration server. It has to create workers in order to test code. Well, that's a permission granted directly to some node, maybe a Jenkins machine, for instance. So if it can create machines, it can create coin miners. And this actually happens more frequently than you would like. Actually, for coin mining, the typical attack vector is leaked credentials or unprotected credentials, somewhere borrowed, quote, credentials that are allowed to do these things. But a workload can as well be a vector for that. So those are the big three with the acronyms that you're going to see a lot of. This one that they're trying to pronounce Kim is kind of a new entrant to the field. The original CNAPP stuff was mostly these two. And then just a whole bunch of other point solutions in there. So how do I deal with containers and serverless functions? Protecting those takes different ways to go. That is a bit of the cloud workload protection. Protecting secrets, checking out infrastructure as code. There are just tons and tons of solutions out there for these issues. And so what Gartner said was, stop the madness. This needs to all be in one place because these things are all related. When I said a vulnerable system that can create other systems, that's a vulnerable system has to do with workload protection. The fact that it was exposed is security posture management. And the fact that it could create other systems, that's identity and infrastructure entitlement. So Gartner said, we got to pull all that together. We can't keep looking at things as just individual items because when you see something that is vulnerable, the next question is, so what? And a CNAPP tries to answer that question for you so that you spend less time looking for alerts and more time looking for attack paths that actually represent risk or that represent higher risk. That's a CNAPP. That's all it is. There's nothing particularly fancy about it. There are a few companies out there doing it, and it's just a combination of all the things that you need. The real power comes from being able to spot combinations that lead to exploit. So what WIZ and our competitors do is, and this is not a, happen to be in sales, but I've only been in sales for a year. The field is looking for combinations. I was talking to a colleague from another company the other day, and they pointed out that the real power of combining all of this is that traditionally as defenders, we've thought in lists. So just here are all my alerts, here are all my vulnerabilities, here are all my possible malware hashes. And they were lists. And so maybe you go through them, or maybe you can prioritize them somehow based on like this CVE has a high score, and it's on, it's in production. But that was all up to you. And the way that attackers think is in connections, in a graph. CNAPP tools tend to use a graph database rather than a relational database. So that when I say, I want to find a combination of something that's exposed, that has a vulnerability, that has too much permission, and that is being actively exploited in the wild, when I say that, that's a graph query. If it was a relational database that just had lists of those different concerns, it's some sort of unholy six-way join to be able to do that, and systems just can't keep up with that. So you have to move to a graph, and that's what CNAPP platforms are doing. It's really the only way to do it. So here's a toxic combination for you. Is we start out saying, hey, I've got a machine that's got a vulnerability on it. It has a pretty good score there, so it's probably something like log4shell. But the next question is, so what? I, plugged stuff in and I noticed that log4shell is on 100 different systems. What the heck? Where do I start? And so by using a graph, thinking like an attacker, you then say, okay, so what? Well, we do have secrets on here, and some systems do need to have secrets on them. At least legacy systems. Hopefully you're moving to a key vault. That's a whole other talk on cloud native. is that you don't have to store secrets on systems anymore. They can just check them out temporarily. But it's got a secret on it that has a cloud identity associated with it. I can adopt a role. Well, what can the role do? I keep asking what if or so what. Well, it can reach a database, and there's internet exposure. And again, we're combining things here. So exposure is cloud security posture management, the vulnerability is workload protection, and of course, infrastructure entitlement, that's the identity there. So you want as much information as possible so that it's actionable, but also so that you have a view that says, when I combine all this stuff, this is like, if I only had Monday out of my week to deal with stuff, this is the stuff I need because it has a terrible combination. So that's what the modern tools are trying to do, is rather than give you, here's 100% of the junk that you need to fix, is say, here's the 10 or 15% that represents 80 to 90% of your risk. Everything's driven by risk and hopefully by business risk rather than just looking at CVEs. So when you look for platforms to do this, make sure you're getting all of that out of them. So this is what we like to say, is that context is queen. Context is everything. Without it, you're not the chess piece that can move in every direction. You're kind of stuck. Which I would argue, if you go with the traditional context as king, you're kind of in trouble because you can only move one square at a time. What you want to do is get out of the business of alerts, out of those lists, and talk about issues to the business. Prioritize it, and now alert fatigue is going to go down a little bit because it's not crazy alerts everywhere. And you need to, number one, think like a hacker. Think about attack paths, but then also let the robots do the boring junk. Because if you can have a system that does it, now you don't have to think as much. You don't have to do all that work. You're not outsourcing the connection making to SIM or IR people, outsourcing it to meat-based middleware, and you have to figure it out yourself. And I have a question. Exactly, yeah. So you start with, I've got a resource and there's a CVE affecting it with a 9.8. And then you look to see in your security posture management, is it exposed to the internet? Yes, all right, we're still at a 9.8. No, all right, let's bring things down a little bit. And let's say that the workload is maybe around a 6. Does it have secrets? Yeah, oh, well, okay, we're going back up. No, okay, we're staying down. So your CNAPP solution won't rank things the way that the CVEs go. If I have a system in a VPC and it can't get anywhere and it can't do anything and it has log4shell, who cares? So that's how we do it. Exactly. Yeah. There are entire tools dedicated to the job of making a human calculate that in the most efficient way possible, but making them calculate it. So those traditional SIM tools, for instance. What are the questions? Anybody else got something on their mind? Yeah. Mm. Yeah, different tools have different purviews. So some tools will look inside of storage. Others will stop short and just say, is it exposed or does it have global write permissions? The question was just about storage, whether it's part of the thing. So different tools focus in different directions. You'll find some that were built by operations people, so they're more operationally focused. Some were built by builders, so they're more about shifting the conversation into the development pipeline. But yeah, storage, classification of data, some people do it, some people don't. I think in the future, everyone will. I think what we're hitting here is that there have been a bunch of companies trying to build themselves up as fast as possible with kind of minimum viable product so that they could sell themselves to somebody else. And I think what Gartner is recognizing is that selling little pieces to different people just kind of doesn't work. You would have to create a graph for all those tools. But yeah, ask your vendors about storage. Make sure you do whatever you need. Let me give you some examples. Here's one example. And again, I'm picking my examples because they are CNAPP things. What I've got here is a workload, and I'm not allowed to go too... How am I doing, Doug? Am I still in the frame? All right, cool. So I've got a workload here that has vulnerabilities on it, so my workload protection is going to kick in over there, and it's got a path out to the internet, so I got my protection there. And it's got all sorts of permissions. The permissions to pass a role, create a user, so pretty darn dangerous, this one here. And then your tools should be showing you your external exposure in a smarter way than just, well, they should be contextualizing it. So they should say, you know, hey, the configuration of the cloud says that I could be listening on this port, but let's just double check that. Again, security posture management, workload protection, those two should be brought together so that you're not chasing after, hey, it's open on port 22, and then the what if is it listening on port 22? No, it's a Windows server. Okay, and then bring that back down. Lateral movement is a big deal. This is how hackers get in there. I was just looking at the cloud threat report from Orca, actually. So I'm happy being vendor agnostic. And they were pointing out that it takes about 3 hops on average of lateral movement to be able to get to valuable data. So this is something you got to keep an eye on. In this case, just as my example, I've got a system that's exposed, and the configuration says it is exposed. And it's got a key on it that then is authorized as root on a bunch of other systems. And one of them is connected to the network as well. So that's 1, 2, there would be a third step in there somewhere. But thanks to being able to figure out that the workload has keys, that the security posture has open access, you're now stitching it together to say, okay, here are the 3 hops, or 2 in this case. And again, I'll keep hammering it home. And again, the Orca report also, similar to ours, similar to Palo Alto, all the people in this area, is the identity, is to watch out for that, is that this is a container that is allowed to get secrets. And it doesn't look like it's got much limitation on which secrets it can get. This happens a lot, and it's not because your developers or your ops people are stupid. They're not. Nobody comes, well, I'm sure there's some people, tech bros or something, but nobody really comes into work thinking, hey, I want to make something insecure, you know, forget it. You don't have the experience or the tools to know that you're making something that's vulnerable. And it happens a lot with containers. It happens a lot with infrastructure as code, things like Terraform and Kubernetes, is that the examples that you find out on the internet are by design insecure. And it's not because there's some nefarious hacker out there, there are few, but it's not because there's something nefarious going on. It's because when you create a Terraform file that, for instance, puts together a WordPress infrastructure, talk about insecure, but when you have a sample like that, you don't know what IPs somebody else is going to want to filter. You know what ports, you know the database should have a password, but the password also, you know, is an example. So it's just, you know, admin password 123, because that's easy to show people, here's how you get started. The problem is, if you don't have tools in place to check this stuff during development, you now have examples that are wide open. And so when I go and I talk to customers and plug stuff in to see how they're doing, there will be all sorts of issues because the examples are wide open, and that is by design. That's not somebody doing something bad. So you just got to keep an eye on that. The more you can shift the conversation to the left in the development cycle, the better off you'll be. Developers are not stupid, but they love getting information in the tools that they use. So the more you can present this sort of thing at development time, the better off, and the developers are more happy too. Shift left is beautiful. Shift left. Show of hands. I love it. All right. A problem that you discover in development, if you don't catch it, it'll become a problem in production, and it'll be magnified. Partially because it's in production, and production is much more dangerous, but also because a single Terraform file that says make me a WordPress site in development makes 3 little systems. In production, it makes auto-scaling systems that all have the vulnerability. So what shift left is a philosophy that developers and security can work together to put checks in at the start of development. So that when I'm a developer and I'm looking at one of those sample code snippets, I can copy and paste it into a file, and I can just right-click in my IDE and say, hey, whatever tool I've got, tell me if this is vulnerable. And then the real magic is when you integrate it into their version control, because they're writing code and checking it into version control. Version control then automatically kicks off some tests. Make sure this function is working, make sure that when I run everything, I actually have a welcome to WordPress page. They're already running tests. If you add one in parallel that just says, hey, go ask my CNAPP if this is vulnerable to anything, it runs in parallel, but it's also the developer's interface. They're used to just try some stuff, push it, let the automatic tests tell me if it's okay. No, all right, fix the thing it flagged, push it, runs the tests. So now they have things in the same exact interface where they push some code. It said, oh, this is an integer, not a string. The function's not going to work. They fix that up. At the same time, it says, hey, you told this thing it could get any secret that it wants. So that's what's going on here. But if you shift left, those things are caught before they become a problem in production. And I was just talking to somebody this morning where we'd hooked up the security people with a CNAPP. We'd gotten it all deployed so that they could see the stuff that was going on in production. They gave a login to the developers, and it took about a week before the developers issued an API key to themselves, plugged it into their version control system, and started to do automatic scans. Like, the security folks didn't even have to do the shift left. They just had to say, hey, here's some stuff you can use, and you won't have to deal with me later. And they got it. That's a whole other talk too, but you can look it up. I think I actually have given a talk on that. I'm not sure. And here's one more example for you. This is a serverless function. Serverless functions are really interesting. They're really valuable. And I think probably most of the mobile apps that you're running right now on your phone are actually hitting serverless functions. All you do for a serverless function is upload your script. You know, it could just be a Python script that hits a database to log you in. All you have to do is upload the script to the cloud. The cloud worries about when an API request comes in, send it to the script. The script does stuff, hits a database, maybe hits some files, and then issues a response. The cool thing is these are really simple to deploy. The tough thing when you're thinking from a legacy standpoint is that, for instance, the traffic that's going to that serverless function, I'm not putting it behind a firewall. It's just too cumbersome, and I would have to configure the darn firewall. It's not going over a network that I control. So maybe I've got, you know, the logs of the network access, but I have to deal with the security in the serverless function itself. And for us as older ops people, we're just not used to that. We're used to the perimeter being the thing. Now it's the workload that we actually have to defend. So this one's a pretty boring, straightforward one. I just have, let's see, well, I've got a Jenkins serverless function here. Not sure where I was going with this one, except to say that it has exposed endpoints, and I might not necessarily know that in a serverless world. Makes it super easy to secure these things too, though. So if you step out of your comfort zone and you think about, hey, all this is a script, and all it does is one little thing, see if my mobile app is allowed to log in if I have the right credentials. That's really easy to secure because it only does one thing. You've now defined the allow list as this thing takes these parameters with these values that are allowed. And you can package that up. It's called policy as code. You can package that up with the function is also the policy of what's allowed to be done. And when you deploy it, deploy your security at the same time as the code. Again, shifting left, telling developers, hey, you know what? You don't have to call up the firewall admin anymore. And she wants to know which networks and which ports and all that kind of stuff. And you have to explain it, and then it goes into the firewall, and then it never comes back out. You can define your own policy when you shift all the way to the left and say, here's my API code, here's what it'll accept. And then just kind of relax. Security has to get hip to those tools as well. It's not a one-way street. They'll have to look at change requests in development and say, okay, that policy looks a little permissive, but there's a lot of teamwork to be had there. Do I have questions so far about anything? I can even be peripheral to the CNAPP. The cloud is a really interesting place. How does the scan work? For most tools, it comes down to a command line interface existing, and an API endpoint in your tool of choice, so that when somebody checks in some code, what the version control system does is it looks to see if there are test jobs to be done, and so it'll compile it and try the functions and things. When it's done compiling it, or even before if it's infrastructure as code, what you can do is just grab your command line tools or hit the API right from the worker that's already testing the features, that's already testing that it's acceptable. And that tends, so far in the industry, it tends to be a command line utility, something nice and small that you just download and run and say, hey, test this. There are plenty of places that you can play with it. If you're an Azure DevOps shop, that's a great place to do it. GitHub Actions, those work really well too. Oh, interesting. A number of different ways. Do you want to shift left on where it's scanning or just in general? Yeah. All right. So in general, the way that it's scanning is a CNAPP will have two components to it, the Cloud Security Posture Management and the Cloud Workload Protection. And the Cloud Security Posture Management only needs to hit the cloud's public APIs. So the same APIs that you would use on the command line if you're using, the AWS or AZ or what's Google one, GCP? I forget the command line for that one. The same APIs that those tools use to say, hey, describe all the instances in my environment, that's how your CNAPP is going to build up the inventory. And then it's going to, from the description of those, it's going to say, okay, I've got these S3 buckets, I've got these workloads, I've got these databases. The metadata on those that says, here's the allow list, here's the deny list, it's going to take those and determine where the risk is from sets of rules. In all the modern tools, you can write your own rules as well. And then from a workload protection standpoint, there are two ways to do it. You can either require people to install an agent on every workload, so kind of still stuck in the EDR world, or there's a method that some folks call side scanning, where what you do is you take all the workloads in the cloud that you spot, you do a snapshot of their operating system disks in your own cloud, so your tools, whether it's WIZ or Palo Alto, whatever, your tools don't need to have a snapshot transferred. So what they'll do is they'll take a snapshot of the disk, do a mount, and then scan through the disk. So it's the disk of a running workload. It's a point in time, but I think that going with an agentless solution is better because you install it, it goes through the cloud APIs to find everything. It uses snapshots from the cloud APIs to do scanning, and you see everything instantly. There are even some places where you can't install an agent. So if you think of virtual firewalls, things like that, you don't get to log in and put agents onto those. The side scanning or disk scanning method will actually be able to do that. We ourselves found when the Log4Shell problem was happening, we found a virtual firewall appliance where the vendor had said we're immune to this issue because they had logged in and poked around and looked at their source code. But a side scan actually revealed that they did have the Log4j issue. Very interesting. Does that answer it? Are the snapshots, does that make sense? It's really clever. It's why I work where I work. It's really neat. All right, let's get started. So demand a real CNAPP. By that, what I mean is make sure that your tools are all integrated into one place, and that the context is calculated. Don't settle for, quote, one pane of glass where disparate tools are all just kind of stitched together. If the data in those tools is not stitched together, you're getting ripped off. Take an inventory of the point solutions that you have because you're going to be able to replace a number of them. With some tools out there, maybe you'll only replace 80% of the functions of a point solution, but the economy of it saves you money, saves you time, and because it becomes part of the contextual calculation, gives you real value. Integrate with the enterprise workflow. Shift left. So if people want their information emailed to them, great, send the information that way. If people have esoteric tools, be able to send a webhook over there. Masochists like to run this stuff into a chat application. Just find the way that people like to work with this stuff and make sure that you can do it. Most, if not all of these tools should allow you to do that. Measuring the value naturally is one of those things that the business people worry about, but you should pick tools that allow you to show progress, to show, for instance, we have 1,000 running virtual machines, containers, and serverless. We had 10 new vulnerabilities happen this month, and we took care of 10 vulnerabilities this month. Be able to show that so that you get to keep your tools the next budget cycle. And then really pick whether you can boil the ocean or not. It's really up to you. I think I'd take kind of a two-prong approach, or a two-step approach, which is integrate a CNAPP into the environment. Even if it replaces point solutions, don't worry yet. Get it operational. Once it is provably replacing those point solutions, then start to turn them off. Save a little money, save a lot of work. And make sure that you're getting buy-in You don't want to call somebody's baby ugly. Some folks will really worry about their job security. So you got to kind of team up and be like, hey, we're doing a proof of concept on this thing. Do you guys want to see it? I've had the smoothest cultural changes when, for instance, folks brought in the developers and said, hey, check this out. Hey, have an API key. Do stuff from whatever tools you have. Let me know what's working for you, so that when you do operationalize, you already know how they're going to want to get that information. And it's really up to questions at this point. I didn't really have a whole lot that I wanted to say. It's very introductory. Any other? No? Do you have any questions?
I do have.
Oh, good. Okay.
And my question is really from my old cohort, and it's what issues are major issues we're going to see in 2 to 3 years that as students we should really start to focus on?
Ooh, what issues should students focus on now? Oh, that is really cool. And a really interesting one, because folks who are dealing with these technologies, they didn't learn it in school. That's similar to the how do I get started in cybersecurity question. And if anybody has an idea, that would be very useful too. I think cloud native resources are really what you're going to want to focus on. And the nature of education, unfortunately, is you can't write a textbook until something really exists. But understanding containers and serverless functions, that's really where everybody's going. Running a single server to do one thing is not cost effective. Folks who just lift and shift all their existing workloads into the cloud, they are spending more money because it's inefficient. So you want to learn about containers and serverless. The sort of implied evolution of things is that folks, and don't write this down because I'm going to change it in a second, folks will start out with virtual machines because they understand them and just run those in the cloud. Plus, you can auto-scale them, so that's useful to know. And then there's sort of been kind of this narrative that like then you do containers, because containers are, so to speak, sort of like tiny little virtual machines that don't take a lot of resources. And then you go to serverless once you actually have been able to scope down to a container. You're like, okay, I'm ready to just have the code. I think that people are going to leapfrog, and I've been asking customers about it, and I am seeing people leapfrog from virtual machine right to serverless and just leave out the containers. Containers have their use for complicated environments where you understand connections and where you still have to sort of think in a legacy. You just need it to be lightweight. But I think serverless is really where we're headed. They're just so darn cheap. And they're so easy because they just do one lousy thing. And then they just, as long as you don't break the way the API interacts with all the other parts, you're able to iterate on a single function at a time. It's really amazing. So I would look at that. Also, we were talking a bit about cloud native resources and securing them. They are fundamentally different. Things like a database as a service, you don't have control of the whole thing. You don't have the underlying system, which can be frustrating if you're used to old stuff, which you have, Zen mind, beginner's mind. You can, you don't have to unlearn anything. But they are fundamentally different. And so microservices as sort of an architecture to pay attention to is going to be useful for students as well. To have individual components that do only one thing, hopefully do it well, but that you can mess with at will, and where your persistent data is all in a database as a service or storage as a service, you can just mess with your code, and away you go. Last thing I'll give to students is you're going to have to, whether you're a developer, security, or operations, you're going to have to start to span a bunch of different things. I'm seeing organizations who are philosophically looking to fill their security roles with developers who then learn more about security. It's going to be an interesting trend. But if you can get a grip on cloud security, you're golden in 3 years. You bet. Anything else? Sure. We got time. Folks can run off if you want. I won't be offended.
Follow-up question.
Yeah.
So I've been going through all the, this is my first convention.
Mm-hmm.
So I've been going through all the vendors, and they're telling me all these great projects
Mm-hmm.
that can help me in the cloud and things like that. But I still sometimes wonder, okay, you have this great project that's going to help me. How is it better than like the Microsoft Defender that's already in there?
Yeah. That's going to be a really interesting shift. If I was you, I would ignore that stuff because it's legacy. I'm being controversial, and probably being a little more brave, but but I think that what you want to look up is there was a blog post a long time about pets versus cattle, or it might have been cattle versus pets. In traditional IT, we used to name our servers, and I loved it. You get a new server and you'd be like, what are we going to name it? And we're like, I don't know. All our other storage volumes are named after dragons. Okay, cool. True story from PlayStation. And so, you would have a server. It was hardware. You had to get somebody to buy it for you. So you love it, squeeze it, and call it George. But if it had a problem, you patched it up. You don't do that anymore in the cloud. What you do is you have infrastructure as code that defines my WordPress, for instance, was the example I was using. My WordPress site is a web, the application, and then database as a service for my persistent data. And there's infrastructure as code that says, here's the definition. Install WordPress version this, install these dependencies version this. And rather than go in and patch a system, especially if it's like a container or serverless, now what you do is you just update the definition and redeploy. So you say, oh, well, my web server now needs to be version 9.1, and WordPress needs to be version 12 or something. I think they're up to 9, actually. And the database is fine because that's somebody else running it. You don't have to worry about George. And you just redeploy. So rather than, take your pet for treatment, you just get rid of your cow or whatever and get a new one that actually works. Yeah, as long as folks are still happy with these.
Follow-up question.
All right.
So a lot of this, especially the as a service stuff, that we keep seeing, and like you said, now Microsoft or AWS is responsible for most of the technical stuff.
Mm-hmm.
Are we becoming like us through the IT folks? Are we becoming less of like technical experts and just more of a this is the product for this and this?
Yeah, you're becoming less of an operations person, which is pretty nice. As a developer, you just want to write code. You may not even want to worry what minor version things are. Like, let the security people say it's now WordPress 9.1.2, and as long as your stuff passes in continuous integration, who cares? Yeah, I think you'll be able to focus more and more on code.
Do you think we lose anything by not having that the old hands-on?
I think I don't think we lose anything by not being as close to the hardware, for instance, as we are. Um, I mean, I've got a motorcycle. I love to like look at the different parts on it, but anything beyond a chain service or an oil change, I'm taking it in just because it's a pain. Like, I mean, I've got a Phillips head screwdriver. I could replace the stupid turn signal that came off it, but I don't think we're losing anything by being farther from the land. Um, in fact, I don't think they're going to be farm to table servers. I think we're not concerned. Um, no, I wouldn't worry about stepping away from the guts. All right, why don't you find me at the booth? Ask me a million more questions. The rest of y'all, I really appreciate your attention and have a great day out there.